In the above diagram, xw is equal to a, xy is equal to b, yz is equal to a plus b, and w is the midpoint of xv. Find in terms of a and or b, simplifying where possible, the vector xv. Now xv is equal to a plus a, and that makes sense because if we go from x, so x is our starting point, and v is our ending point. So that means that we have to go from x to w, and then from w to v. Now, the good thing is that we know that w is the midpoint of xv. And so that means that it's halfway. And so what does that mean? Well, that means that, okay, that means that if we know that x w is a, then that means that wv must also be a as well, right? Because w is the halfway mark. And so if xw, but that means that xw and wv must be equal in length. So if xw is a, that means that wv must also be a. So xw is a, so that's how we got this first a, and then wv is also a, so that's how we got the second a. And so we have a plus a, and a plus a is definitely 2a. So xv is equal to 2a. Okay, next we have xz. So xz means that we start at x and we end at z. And so that means that we're gonna start at x, but we're gonna end at z. So we're gonna go from x to y. We're gonna go from y to z. So x to y is b, and that's why we have b here, because x to y is b. And then from y to z is a plus b, and so that's why we have a plus b here. Now we have this expression, we have to simplify it, and so we bring all the b's together. So we have a plus b, and b plus b is simply 2b. So we have xz is equal to a plus 2b. So if we're going from x to z, the simplified version of that is going to be a plus 2b, all right? Next, we have so xz is equal to a plus 2b. Okay, so next we have to figure out what is v to z, the vector vz. So what does vz mean? Vz means that we start at a, all right, and we end at z, okay? Now, what do we know? Well, we do know that wv is still a, right? That's still vector a. And we know that because w is the middle, w is the midpoint, all right? But we are trying to go from, so w is the midpoint, so that means that if this is a, this must also be a as well. But we are trying to go from v, because remember, this is v to z. So we start at v and we try and end at z, okay? So we're trying to go from v to w, and then from w to x, okay? And so what does that mean? Well, if we go from v to w, that's going to be negative a. And it makes sense that it's negative a because going in this direction is a, but going in the next direction is negative a. And if we go from w to x, that's going to be negative a again because we are going from w to x. That's the opposite direction. Now, if he's going from x to w, then it would have been positive a. But we're going from w to x, so that's going to be negative a. So from v to w, that's negative a. And from w to x, that's negative a as well. And so that means that vx is equal to, so vx, so vx, right, is actually equal to negative a, right, and negative a. What is a negative a and negative a? Well, negative a and negative a is going to be negative 2a, all right? And so that's what vx is equal to. So if we're trying to go from v to x, that's going to be negative 2a, all right? Okay, so So now that we have that, now we have to go from, so once we go from V to W, then from W to X, then we need to go from X to Y, then from Y to Z. And so what do we have? So VZ is equal to Vx, so V to X, and then from X to Z. So we go from X to Z, all right? Now, what do we know about Vx? Vx is equal to, we just figured that out. Vx is equal to negative 2a. That's what Vx is equal to, negative 2a. And xz, we just figured that out as well. In the previous question, we saw that xz, which is from here all the way to here, can be simplified as a plus 2b. And so that means that vz is equal to negative 2a plus 2b. Now, what is negative 2a plus a? Well, negative 2a plus a is simply negative a. So we have vz is equal to negative a plus 2b. We cannot simplify this any further because a and b are not like terms. And so we have to leave it like that. So vz, the vector vz is equal to negative a plus 2b. And that's the answer to this question.